Hi everyone, in today's video we are going to discuss the basics of AC circuits. We will start by understanding the DC first and then move on to AC. When a DC source like a battery is connected to the circuit, the current always flows in one direction. Conventionally, we represent from the positive terminal of the battery to the negative, always in one direction. And also the magnitude of the current remains constant over the time. So, we represent like this straight line on the graph. Even the voltage is the same, the constant over the time. Whereas, in the case of the AC, for example, when we connect the AC source to a circuit, the direction of the current changes periodically. First, suppose say it is moving in this direction, okay, then it will change its direction periodically. So, back and forth movement will be there for the current, and also the magnitude also changes. For example, here say this the voltage or you say current, the current is initially 0, reaches the maximum value and then reaches back to the 0 value in one direction. When the direction changes, the same thing we can observe, starts from 0 and then reaches the maximum value and then back to the 0. So, this whole thing is called one cycle. One forward and backward direction is called the whole cycle. So, we represent this one as positive, this one as the negative, that is it. So, here in this picture they are showing the two cycles. Okay. We will discuss the equation for the AC current and AC voltage. So, as the direction is reversing periodically, the magnitude is changing with the time. So, we can represent with the help of the mass, that is the equation. So, the voltage at a time t is given by the maximum value times sin 2 pi f t, where the f is called the frequency. We can also represent with the cosine function. So, but we follow only the sine in this video. The similar equation we can get it for the current. So, the current at any time is given by the maximum value of the current sin 2 pi f t. So, that is called the instantaneous current. This is the equation for the instantaneous voltage and this is the equation for the instantaneous current. Let us do some problems on this. Equation is given V of t equal to 170 sin 2 pi 60 t. Okay. Why we have to calculate the maximum voltage, we have to calculate the frequency and the time period. So, compare the given equation with our standard equation, that is V of t equal to V max sin 2 pi f t, sin 2 pi f t. Okay. Maximum voltage. So, it is very clear, the maximum voltage is here. So, first one, the answer is V max equal to 170 volts. The second one, the frequency, compare the equations. So, exactly matching. So, the frequency becomes 60 hertz, the units of the frequency is hertz. The third one, we have to calculate the time period. So, very easy, we know the time period and frequency simply the reciprocal to each other. So, 1 over 60. So, use the calculator, 1 over 60. The answer is 0.01666 something. So, time period, the SI unit is second. Second question. This time equation is not given, whereas the waveform is given. Okay. So, it is like this, it is going up and then down like this, one cycle is given to us. Okay. So, we have to find this following parameters. First one, the maximum voltage, it is very clear here, this is the maximum voltage, that is equal to 10 volts. The time period, so time period means the time taken to complete one cycle. So, that is it. So, remember here the time is given in micro, micro means 10 to the power of minus 6. So, the time period is 20 microsecond, and then we have to calculate the frequency. Frequency is equal to 1 by time period. So, that is equal to 1 by 20 microsecond, which is equal to 1 over 20. Micro means 10 to the power of minus 6, which is equal to 50,000 hertz. Then we have to calculate the voltage at 1 microsecond. So, here the voltage we have to calculate. So, the voltage is around 3.1 volt, voltage at 2.5. So, from the picture 7.07 volt, voltage at 10. So, voltage at 10 is here. So, it is 0, voltage at 11. So, minus 3.1, the voltage at 12, it is minus 5.9 volt, and lastly we have to write the equation. So, the equation is V of t equal to V max sin 2 pi f t, which we know it. So, which is equal to V max, the value is it is 10 sin 2 pi, f value is 50,000, the time, that is it. This is the wave equation. Next question, some equation is given. So, this is for the instantaneous current equation. So, I of t equal to sin, sorry, okay, the pointer is missing for me. Okay. So, I of t equal to 141.4 sin 314 t, something is given. We have to find the maximum value of the current. Let us compare with the standard equation. I of t equal to I max sin 2 pi f t, that is it. So, here I want to tell you 2 pi f is called the angular frequency. Okay. In some books we can also find the instantaneous current. The equation will be like this: I of t equal to I max sin omega t, like this also we can find it. Okay. Okay, whatever it may be, we have to find the maximum current. So, compare with this one, the maximum current is equal to 141.4 ampere. Then the frequency, okay. So, 314, this is the value of the angular frequency, 314. So, from here I have to calculate only the frequency, 314 divided by 2 pi, 314 divided by 2, the answer is nearly 50 hertz. This is the second one, and then the time period, which is equal to 1 by f, which is equal to 1 by 50. So, which is equal to 0.02. Time period means second unit. Then we have to find the instantaneous value of current when t equal to 3 millisecond. Milli means 10 to the power of minus 3. Okay. Instantaneous value I of t equal to I max 141.4 sin 2 pi f t. 2 pi f value directly given. So, 314, that time is 3 millisecond, 3 times 10 to the power of minus 3. Okay. We have to remember the angular frequency, that is omega, the SI unit for it is radian per second, So it means that we have to keep our calculator in the radian mode, and then we have to solve this problem. So the answer becomes 141.4 sin 314 times 3 times 10 to the power of minus 3. The answer is 114. 114.35 I got. This is the current when t equal to 3 millisecond. Okay. Next problem. Okay, there is no problems. We have to discuss the effective value of the AC. So whenever AC circuit comes, we always use the effective values, that is the RMS value. What is meant by RMS? RMS stands for root mean square. We use only root mean square because we have maximum values, we have the zero values. So over one cycle the current value becomes 0, the voltage value becomes 0 over one cycle. So the effective value in this one is the RMS value. So what is RMS? So simply we can define as it is the amount of AC power that produces the same heating effect as an equivalent DC power. So look at here, suppose when we connect a resistor, or you say the bulb or anything is connected to the DC source, suppose it is giving out some heat energy. I want the same amount of heat when we connect the same resistor to a AC source. This is possible only with the RMS values, then only the heat produced by this and this are the same. So that's why we take the RMS values. So there is one relation, simple relation between the RMS values and the peak values, that is the maximum values. So IRMS equal to I max over root 2, the VRMS equal to V max over root 2. Very simple. Okay. Let us do a problem on the RMS and the maximum values. For an electrical appliance, the rated AC voltage, remember it is given AC voltage. AC voltage means the RMS voltage. Okay, RMS voltage is given as 120 volt and the AC current. So this is the RMS value 10 ampere. What are their maximum values? Okay, so maximum values we have to find. So V max we have to find. So the direct formula is root 2 times the VRMS. That's it. So which is equal to root 2. The VRMS value is 120. The answer is 120 times root 2. The answer is 169.7 volt. The same thing for the maximum value for the current. I max equal to root 2 times IRMS. So the answer is root 2 times the 10. So which is equal to 14.14 ampere. Now we are going to explore three important components in the AC circuits, that is resistors, capacitors and inductors. First we will study what happens when only resistor is connected to an AC supply. Then we move on to understand the behavior of the capacitor in the AC circuits. Then finally we will look how inductor responds when the when it is connected in the AC circuits. At each step we will observe how current and voltage behave and how each component affects the circuit differently. Let us get started. when only resistor is connected to a AC circuit. Observe what happens to the voltage and the current. When a resistor is connected with the AC source, the voltage and current reaches their maximum and minimum values at the same time, and they are said to be in phase, or you can say in step with each other. This is the behavior. So, they are in phase with each other, voltage and current, when only resistor is connected in the AC circuit. You can say the phase difference between the voltage and current is 0 degree. Let us study some more things, that is the instantaneous voltage, instantaneous current and instantaneous power. We use the equations for the instantaneous voltages. These equations we discussed before. Now, the extra thing is the power. The power formula is voltage multiplied by current. Okay. Now, move on to the average voltage, average current, average power. So, in this AC circuit, when only resistor is connected in the AC circuits, the average of the voltage in one cycle becomes 0, and the average of the current also in one cycle 0, but the average power is not 0 in one cycle. The average power is given by the Vrms times Irms. Another, we can also write in terms of the maximum, Vmax Imax over, remember the important thing, the 2. The resistance, the total resistance in this circuit we can calculate with the help of the Ohm's law, that is R equal to Vmax by Imax, or we can also take Vrms by Irms. Okay. So, the power in this when only resistor is connected in the circuit, so average power is not 0, it is having some value. So, the power, you can say the power is consumed in the circuit and it will emit as the heat. Heat is liberated here, emitted. Okay. Let us do some problem on this. An AC voltage source has an output of V of t equal to 200 sin 2 pi f t. Some equation is given for the instantaneous voltage. The source is connected to a 100 ohm resistor. Okay. As shown in the figure, find the RMS current, the maximum current in the resistor. So, first we will from the given thing. So, this is our the maximum. So, the given thing is V max equal to 200 volt and the resistor is given. So, that is 100 ohm. So, using the Ohm's law we can find the I max. We will find the I max first. So, the Ohm's law triangle is given here. So, I equal to V over. So, max is given. So, we have to write the max only, that is it. So, V max equal to 200 over the resistance is 100. So, which is equal to 2 ampere. Finish. Now, what we have to find? The RMS current. So, RMS current we can get it by the formula is this one, I max over root 2, I max over root 2, that is it. So, I max value is just now we got the 2 divided by root 2. So, which is equal to 1.414 ampere. Now, move on to, that is it. We have done the this one RMS current we got it and the maximum current we got it. Let us move on to the second problem. An RMS voltage is given, that is 100 volt, is applied to a purely resistive load of 5 ohm. R, this is the RMS, PRMS. So we have to find the four things. That is, the first one, we have to find the maximum voltage. So very easy, the maximum voltage we can get it by, yes, this is the formula, maximum voltage we can get it by root 2 times the VRMS value. So which is equal to root 2 times, that is 100. So which is equal to 141.4 the voltage, the B bit. That is, we have to find the RMS current. So this is the formula we are going to use. Okay. So RMS current we have to find. Okay. First we will find with the help of the Ohm's law we will find. Okay, that is better. The current, because we know the voltage and resistance, so we use the Ohm's law. I RMS we can get it by the Ohm's law, that is V RMS over the resistance. So V RMS equal to 100 over the resistance is 5. So which is equal to 20 ampere. The third one, the maximum current we have to find. So now we will use this formula, I max equal to root 2 times the IRMS. So which is equal to root 2 times the IRMS is the 20. So sorry. So the answer is 28.28 ampere. The last one, that is, we have to find the power dissipated. Power dissipated, we can use the formula, the last formula here. Either we can use the RMS values or we can use the maximum values, it's up to us. So RMS values, let's use VRMS multiplied by IRMS. VRMS is given, that is 100, and the IRMS we got it as the 20. So which is equal to 2000. Power, the SI unit is watt. Next problem. What is the resistance of a light bulb? What is the resistance of a light bulb? That uses an average power. Average power is given. So P average 75 watt. When it is connected to a 60 Hz power source with a peak voltage of 170 volt. Okay, we have to find the resistance. That's it. So average power is given to us, and also the peak. Peak is also called the max. Okay, so here it's very clear that we are going to use the average power formula. So that too in terms of the maximum values, that is V max times I max divided by the 2. This is the formula we are going to use. Okay, so 75 equal to the V max is 170 times I max we have to calculate, and then the 2. So cross multiply 75 multiplied by 2 over the 170. This is the value of the I max. Let's put the values in the calculator. 75 multiplied by 2 over 170. The answer is 0.88. This is the value of the I max. This is in ampere. Okay, what to calculate here? What is the resistance? Okay, we apply the Ohm's law. We apply the Ohm's law. Now we apply the Ohm's law. So we will calculate the resistance with the help of the voltage over the current. So which values we can use? We will use the max, because we know only the maximum values. So which is equal to the voltage equal to 170 over the current. Just now we got 0.88. Let's see the answer. 170. So the answer is 192 point nearly 7 ohms. This is the first part. Now we have to find the second one. What is the resistance of a 100 watt bulb? So everything the same. The only difference is this time we have to replace with 75 with the 100. That is the only difference. Come on, you do it. Okay. Third problem. An AC power supply produces a maximum voltage of 100 volt. This power supply is connected to a 24 ohm resistor. Okay, and the current and resistor voltages are measured with an ideal AC ammeter and an ideal AC voltmeter as shown in the figure. What does each meter read? Recall that an ideal ammeter has 0 resistance and an ideal voltmeter has infinite resistance. Okay. So, look at here, it is given AC ammeter, AC voltmeter. Remember, these will give you the values only the RMS. Okay. It means the ammeter will give you the RMS values and this voltmeter will give you the RMS value. That is it. So, okay. So, what is given to us? Vmax. Okay, it is very easy. Let us convert. First find the Vrms, that is equal to Vmax over root 2. So, which is equal to 100 over root 2. So, which is equal to 70.7 volt. Now, for IRMS we will use the Ohm's law. That is better because like Imax is not given. So, Ohm's law is better. So, that is IRMS equal to Vrms by the resistance. So, Vrms just now we got 70.7 over the resistance 24. Let us check how much is the answer. The answer is 2.94. 2.94. SI unit is ampere. Okay, now we will move on to the capacitor part. What happens when a capacitor is connected to the AC circuit? Okay, capacitor is connected to the AC source. Observe what happens to the voltage and current. It is very clear that there are some values, the voltage and current values are there, but they are at a time they do not have the same values. Here it is looking that one value, when one value is reaching the maximum value, another value is becoming the 0, like that. This is the behavior. Let us study more. Before going into this one, we will understand the phase concept, okay, with the help of this one. Okay. Suppose the cycle starts from this point and the cycle is completed. One cycle is completed. The time taken to complete one cycle, we call it as the time period. We represent the time period that is capital T. The same thing we can also represent with the degrees. One cycle, one complete cycle is represented with 360 degree, or in the radians it will be 2 pi. Okay. Now we will discuss some important, very useful concept. Let us mark this point as A, this is as B, then C, D, E, F, like this, so on. Okay, let us discuss. The starting point is the A and this one is the B. So, B is at, in terms of degree if you are discussing, the B is at 90 degree. Okay. Suppose we are going to discuss the phase difference, the very important topic, the phase and the phase difference between the 2 points on the same wave. Okay. For the point A and B, the phase difference is 90 degree, because the point A is at 0 degree, the point B is at 90 degree. So, the phase difference between A and B is 90 degree. Okay. And one more, this is called the 0 line. The point A is at the 0, the point B is at the peak, the maximum value. Okay. Now, let us discuss what is the phase difference between the point B and the point C. The phase difference is also very clear here. The B is at 90 degree, the C is at 180 degree. So, the phase difference for B and C also 90 degree. Now C and D also the same 90 degree, D and E also the same 90 degree, E and F also the same. So one interesting thing we can find that one point is at the maximum, whether it is in the positive direction or negative direction, another point is at the 0. So remember, point A, point C, point E, so this is the 0 line, this is the 0 line if they are at the 0 line. Okay, like this. So one is, so point D and point E, one is at the maximum, another one at 0. It means point D and point E, the phase difference between them is 90 degree. This shortcut will be useful for us. Okay, let's discuss what happens when a capacitor is connected to a AC circuit. So observe here, this is the voltage waveform, this is the current waveform. Observe, who reaches the, first question is which one reaches its peak value first? Is it the voltage or is it the current? So peak value, so for the voltage this is the first peak value and this is the first peak value for this one. Okay, so in the beginning itself it has reached, the current has reached its peak value, the maximum value. So here is this one. So the answer for this one is the current has reached the peak value first. Very good. So one is at the peak, the maximum value. Okay, let's observe, take any point, any peak value, compare one peak value with the other value. Here we observe that the another value here is at 0. One wave is giving the maximum, another is at the 0. So it means there is a phase difference between them. So the phase difference between them is 90 degree, or you can say pi by 2 radian. So in short, we can say when a capacitor is connected in the AC circuit, the voltage and current, they will not reach the same values, or at a time they will not give the same values. So one is at the maximum, another one at the 0, like that behavior. So in short, you can say the voltage, or you say the current is giving the maximum value first. So we will say the current leads the voltage by 90 degree phase, or in the opposite also we can say, if you want to say the voltage, the first voltage lags behind the current by 90 degree. Clear? Let's study some more things. So this is the circuit symbol for the capacitor is connected to a AC source. So of course in this circuit also there will be some resistance offered by the capacitor. So the resistance offered in this circuit, we call it as the capacitive reactance. Reactance we represent with letter X, whereas the capacitive, because this is the reactance, we got it because of the capacitor, we represent the capacitive reactance with the letter XC. That's it. Okay. The SI unit for this one XC capacitive reactance is because it's a resistance, so the SI unit for this one is the ohm. Like that. So this capacitive reactance depends on the frequency. This is the formula. So X equal to 1 by 2 pi Fc. So F is the frequency, whereas C is the capacitance of the capacitor. Capacitance of the capacitor. The SI unit for this capacitance is the farad. Simply capital F. We usually in our labs we use microfarad, millifarad, nanofarad capacitor, because the farad is very big unit. Okay. So here the Ohm's law also valid in these circuits, AC circuits, that is V equal to IR. The only difference is that in place of resistance we use the capacitive reactance. That's it. X, that's it. This is the formula. Let's do some problems. on this. Okay, before going into this problem, let's study the capacitive reactance and the frequency connection. Okay, for a given capacitor. So, for a given capacitor means only one the same capacitor we are using, the capacitor we are using the circuit, only we are changing the frequency of the AC source. Okay. So, what happens to the XM, the capacitive reactance? So, they are inversely proportional. Let me write. So, if from the picture very clear, Xc is inversely proportional to the frequency. If the frequency increases, the Xc value decreases, inversely proportional. Okay, let's do some problems on this one. What is the maximum current is delivered by 2.2 microfarad capacitor? So, capacitance is given, it's 2.2 micro means 10 to the power of minus 6 farad, is connected when connected across a North American outlet, okay, and European outlet. We have to find the maximum current. Okay. Remember, we have two different types of outlets we are using. The Americans, they use one outlet where the frequency is high, the voltage, the RMS voltage is less, whereas the European outlet, they have the less frequency and the more RMS voltage. Okay. Whereas we are using the same capacitor for the same in the both outlets. So, let us calculate for the North American outlet. Okay. Capacitor is the same. Okay. Let us what to calculate the maximum current, I max we have to calculate. Okay. The capacitance is given. First we will calculate the Xc first. It is easy for us. Xc we will calculate, that is 1 by 2 pi Fc, okay, which is equal to 1 over 2 pi. The frequency for the North American is the 60, the capacitor we are using is 2.2 times 10 to the power of minus 6. So, 1 over 2 pi one two zero 1205.7 ohms. Now, it is easy for us to find the maximum current. Okay. Before the maximum current, because the Vrms is given, we will calculate the Vmax first. Vmax equal to, this is the formula we are going to use, Vmax equal to root 2 times Vrms. So, which is equal to root 2 times 120. So, answer is 169.7. This is the voltage. Now, we can calculate the Imax using the Ohm's law. Imax equal to, this is the Ohm's law, Vmax over the resistance. So, that resistance we are calling it as, in the case of capacitor, that is Xc, that is it. So, Vmax equal to 169.7 over the Xc value is 1205.7, which is equal to answer is 0.1407 ampere. We finished for the North American outlet, the B part. For the European outlet, the same capacitor we are using. So, the same procedure we have to follow. Okay, that is it. I hope you will do the second part. When 4 microfarad capacitor is connected, 4 microfarad, so capacitance is given that is 4 micro 10 to the power of minus 6 farad. Capacitor is connected to a generator whose RMS voltage is given Vrms. The current in the circuit is observed to be 0.3. So, this is the current. So, Irms is given. What is the frequency? We have to calculate the frequency of the source. Okay. So, what is the frequency? Frequency we are getting in this formula. So first we will calculate the XC. So, using the Ohm's law, XC equal to, from the given equation, Vrms by Irms is better for us. So, which is equal to Vrms is 30 over 0.3. So, which is equal to 100 ohms. This is the answer. After that, we can calculate, we will use the full formula for Xc, that is Xc equal to 1 by 2 pi Fc. That is it. So, we can rewrite this above formula because we have to find the frequency, that is 1 by 2 pi the frequency and Xc multiplied by the capacitors. So, 1 by 2 pi Xc value, just now we got 100, the given capacitance is 4 micro, that is 4 times 10 to the power of minus 6. Use the calculator. The answer is 397.88. So, roughly like this. So, frequency, the SI unit is hertz. Next problem. What maximum current is delivered by an AC generator? Maximum current with Vmax. So, Imax we have to calculate when Vmax is given, frequency is given and the capacitance of the capacitor is given. Okay. So, from this information, first we will calculate the XC, Ohm's law, that is the voltage divided by the current. So, which one we will take? The max we will take. Okay. So, Vmax is how much? 48. Imax we do not know. So, we will wait, we will stop here. First, we will use another formula, Xc equal to 1 by 2 pi Fc, that is equal to 1 by 2 pi, frequency is given as 90 hertz, the capacitance of the capacitor is 3.7 micro farad. Okay. Let us calculate first this one. 1 divided by 2 pi times 90 times 3.7 micro. Answer I got as 477.9. So, I can take it as 478 ohms nearly. Okay. That is it. So, we can use this formula, we can use the Ohm's law. So, we can rewrite. So, Imax I have to calculate. So, which is equal to Vmax over the Xc. So, which is equal to Vmax is 48 divided by the Xc value 478. So, the answer is nearly 0.1 ampere. Okay. That is it. So, very easy, the problems are very easy. We always most of the problems we can solve with Imax and RMS value conversion, max to RMS, and with the help of the Ohm's law and with the help of another formula. Okay, Xc. One more problem, what value of the capacitor must be inserted. Okay, what value of the capacitor inserted in a 60 hertz circuit in series with a AC generator of 170 volts maximum output voltage to produce an RMS current output of 0.75. Okay. So, what is given to us? The frequency is given to us. Okay. Vmax is given to us. RMS current is given to us. Okay. What value of the capacitor? So, finally, we have to find the capacitance of the capacitor. We have to find. Okay. So, the capacitance of the capacitor we have only here, that is at C. So, we will calculate the XC. Come on. So, first we will calculate the XC, which is equal to either we have to use the max B max by I max. So, which the direct max is not given, or we can use Vrms by IRMS. RMS value is also not given directly. So, we will wait, come on, we will find the Vrms first. Vrms equal to Vmax over root 2. This is the formula. So, 170 over root 2, which is equal to 170 divided by root 2. It is around 120.2 volts. That is it. Now, we can use the XC, that is equal to 120.2 over the IRMS value is given, that is 0.75. The answer is 160 point nearly 3. The SI unit is ohm. So, we got the XC. Now, we can use the formula XC equal to 1 by 2 pi FC. So, this is the formula. So, from this we can get the C value, that is equal to 1 by 2 pi the XC multiplied by the C. So, which is equal to 1 over 2 pi the XC, we got it as 160.3. The capacitance of the capacitor, sorry, I did why I did one extra, this is not required. What is the mistake I did? X equal to 1 by 2 pi FC, I have to calculate this. So, the frequency is must, this is the formula, 2 pi, the frequency is the 60 hertz multiplied by 160. Okay, let us use 1 over 2 pi times the frequency, that is 60, time the XC value we got 160.3. The answer is 1.6547, or you can say nearly 655 times 10 to the power of minus 5. So, this is the capacitance of the capacitor. The SI units are the farad. Now, we are going to discuss the last question in the capacitor case. The generator in a purely capacitive AC circuit has an angular frequency of 125 radian per second. Angular frequency omega is given. Vmax is equal to 140 volt and the capacitance C is equal to 6 microfarad. What is the RMS current? We have to find. Okay. So, the given thing is angular velocity. We know omega is the angular velocity. So, the formula for the angular velocity is 2 pi f. The angular velocity is given 120 pi. So, we have to calculate the
only the frequency, that is equal to 120 pi by 2 pi. Pi cancel, 2 ones are this one's 60 Hz is the frequency. Finish. Then Vmax is given, capacitance is given, what is the RMS current. So before that RMS current, we find the capacitive reactance Xc. So that is given by 1 by 2 pi Fc. So which is equal to 1 by 2 pi, the frequency is 60, the capacitance of the capacitor is 6 microfarad, 6 times 10 to the power minus 6. The answer is 1 over 2 pi times 60 times 10 to the power. I got nearly 442.1 ohm. RMS current we have to find. Okay. Before the RMS, okay, let's apply the Ohm's law. Ohm's law. So let's calculate the Imax first. Imax equal to Vmax over the Xc. That's it. So Vmax is given 140 over Xc value 442.1. 140 divided by answer. That is equal to around 0.3167 ampere. Now we can calculate the RMS current. The formula is RMS current equal to the maximum current over root 2. So which is equal to 0.3167 over root 2. The answer is 0.22 ampere. Now we are going to discuss the last part, that is the inductor in the AC circuit. We can also call it as pure inductive circuits. Okay. What happens when we connect inductor in the AC circuit? So observe the voltage and current graphs. So this is the voltage, this is the current graph. Observe there is something is happening. So they are not moving in phase. So if one is going maximum, another one is 0, like this. The behavior is like this. One is at 0, another one is at the maximum. Okay. Let's stop the motion and analyze it. So we can see here, this is the voltage, this is the maximum value. So this is the maximum value. So at the same time, what is happening here? So here, this is the 0. One is at the maximum, another one is at the 0. It means there is a phase difference between these two waves, between the voltage and current, that is 90 degree, or we can say the phase difference is pi by 2 radian. Another thing, which one reaches its peak value first? So maximum value first. Look at here. So the voltage is reaching in this time, this much time. In the same time, look at, this is the maximum value, the first maximum value. In the positive side we are looking. So this much time it is taking. It means that here the voltage is quickly reaching the maximum value compared to the current. So you can say that the voltage is leading here by how much phase? 90 degree. So in short, you can say the voltage across the inductor leads the current by pi by 2 radians or 90 degree. So here also, in this circuit also, we have some resistance. Okay, that resistance given by the resistance means the opposition to the current. So that resistance we call it as the reactance. Okay, reactance we represent with letter X. This is due to the inductor, so we represent with the L. So XL is the inductive reactance. So here also the inductive reactance also depends on the frequency. So it is the direct relationship. If the frequency of the source, if the frequency of this one AC source increases, the XL also increases. If it decreases, it will also decrease. So the relation between XL and F is directly proportional. For a given inductor. So L, what is L? L is the inductance of the inductor. Inductance of the inductor. And the SI unit for L, the inductance, the SI unit is Henry. Simply capital H, Henry. So here also the Ohm's law works very well. So V equal to IR. The only difference is that in place of R, we have the XL. That is the inductive reactance. The SI unit for XL is Ohm. Let's do some problems on the inductor. It's given in a purely inductive AC circuit, Vmax is 100 volt. This is fixed. In the question, this value Vmax is 100 volt. If the maximum current is 7.5 ampere at 50 Hz frequency, calculate the inductance. L we have to calculate. Inductance means this is the formula, last formula we have to use. So XL equal to the first one we are answering. The first one XL we will calculate, which is equal to we cannot directly find the XL, so we use the formula Ohm's law, that is Vmax over the Imax we will find first. So which is equal to 100 over 7.5. So 100 over 7.5, the answer is nearly 13.3 ohms. The XL. Now we will use the another formula, XL equal to 2 pi FL. So from this we can calculate the L value and the L as the subject, so it becomes XL over 2 pi F. That's it. So XL is 13.3 divided by 2 pi the frequency. So here the frequency is 50 Hz. So the answer is nearly 0.042. So inductance, the SI unit is Henry. Now move on to the B part. At what angular frequency omega? So we have to find the omega. So omega is coming into the picture. Just now we learned about the omega. Angular frequency we represent with the letter omega. So which is given by 2 pi F. So maximum current is 2.5 ampere. So in the second case, the Vmax is as it is, we are not changing, that is same 100 volt. So the maximum current is 2.5. So under these values we have to find the omega. So for this we have to find the omega. So whatever it may be, we will find the value of XL first. So XL equal to Vmax by Imax. So which is equal to Vmax is 100 divided by 2.5, which is equal to 100 divided by 2.5. The answer is 40. XL is 40 ohm. Now we can calculate the omega here. So we know XL equal to 2 pi f L. This is the formula. So we can write in terms of omega, that is equal to omega L. So we have to find the omega. Omega equal to XL divided by L. So XL value is 40. We know for a given inductor the inductance is the fixed. L value is the fixed one, which we got it as 0.042, which is equal to around 952.4 omega angular frequency. The units are radian per second. Last question in the inductor case. So an inductor is given 54 ohm, reactance at 60 Hz frequency. What will be the maximum current if this inductor is connected to 50 Hz frequency source that produces a 100 VRMS voltage? Okay, so remember the relation here, the frequency with the XL. So we know for a inductor XL equal to 2 pi FL. This is the formula. So for a inductor, it means that we are keeping the inductor constant. So this part L is constant. Same inductor we are using in both the cases. Then what is the relation between XL and F? The relation is direct relationship. That's it. If the frequency increases, XL increases. So observe here, the frequency before 60 and the XL value. So the before the first case, this is the frequency F1, the value is XL1. Now the frequency is decreased to how much? 51. The frequency is 50. Then we have to calculate how much will be the XL. How much? Obviously, if the frequency decreases, XL also decreases. So we are expecting less than 54 ohm. Okay, so in these cases, when two comparisons are there, two cases are there, we can write like this: XL1 over XL2, which is equal to F1, because all other things are constant, F1 by F2. So let's substitute all of them. XL1 is 54 over, we don't know, XL2 we have to calculate. The frequency is 60 over the 50. So let's rewrite. We have to calculate XL2, which is equal to 54 times 50 over the 60. 54 times 50 over 60. The answer is the 45. Yes, we got the answer less than 54. Okay, what we have to calculate? The maximum current. What will be the maximum current? Okay, Vmax we have, Imax we have to calculate. So obviously we use the Ohm's law. Imax equal to Vmax over the resistance. Here the resistance is the inductive reactance XL. That's it. So we will calculate the, okay, Vmax is not given, so meanwhile we will calculate the Vmax value from the VRMS value. So Vmax equal to root 2 times, this is the formula, times VRMS, okay, which is equal to root 2 times 100, so which is equal to 100, 141.4 volts. So substitute here, so which is equal to 141.4 divided by 45. The answer is 3.14. SI unit is ampere. So that's it. We have finished all the problems related to this one, and this is the summary whatever we discussed: the circuit diagrams, the waveforms, the Ohm's law, the effective resistance value, and finally the power value. Everything is given here. This is the whole summary. So that's it from my side. Thank you very much. All the best.